So here's a very classic physics problem. It's a sliding block problem. We have a 100-pound block resting on an inclined plane that's tilted at an angle of 20 degrees to the horizontal. So this is a 20-degree angle. And we also know that the magnitude of W here is 100. The vertical vector W represents the force or weight. That's the force due to gravity exerted by the object. And it can be decomposed into two pieces. One piece is going to be parallel, that should say PAR, a piece that's parallel to the plane, and a piece that's perpendicular to the plane. W par and W perp, we're going to call them. First of all, before we actually calculate those values, the first thing that I'd like to mention is why might we be interested in those two things? Well, typically a sliding block problem is about will the block slide or not. And if you can imagine, this W parallel vector is trying to pull the block down the plane, while the W perpendicular vector is trying to get it to sit right down perpendicular to the plane. So there's something about the relationship between those two vectors that's going to determine whether or not this block is going to slide. So we're going to start by just calculating the parallel and perpendicular vectors, and then we'll go ahead and look at the conditions for sliding. So first of all, let's talk about W parallel. If I were to put some axes in here, I'm going to use this as my origin. Then I know that since this is a 20-degree angle, let me see, I'm actually going to go ahead and include a few dotted lines here as well. Let's drop some perpendiculars there and there. I can definitely see some similar triangles going on here. And so since this is a 20-degree angle, I can see that that would be 20, meaning this would be 70, meaning that that would be 20. Might as well finish. This is 20, this is 70, that's 70. So we've kind of got our angles all labeled. All right. As far as W parallel is concerned, I'm going to start by saying, let's think about the magnitude of W parallel. The magnitude of W parallel right here would be, let's see, the hypotenuse is 20, or is 100 rather, and this would be opposite the 20-degree angle, so I could do a 100 sine 20. And then the direction, well, if I look at the direction, that angle is 20 degrees, but it's technically negative 20 degrees from the x-axis. So what I'm going to do is I'm just going to say the cosine would be positive, so cos 20 degrees. And then instead of writing sine of negative 20 degrees, I'm just going to put in a negative sine 20. You can either think of it as the negative angle identity or just the fact that it's pointing downward, so it has to be negative in the y direction. So I've got the length, I've got the direction. If I just multiply the magnitude by the direction, I've got W parallel. So for the x, I'll have 100 sine 20 cos 20. And for the y, I'll have a negative 100 sine squared 20. All right, let's look at W perpendicular over here. The magnitude of W perpendicular first. So again, looking over here, thinking about this triangle, the hypotenuse is 100 again. And I'd like to put everything in terms of the 20-degree angle. So I'm thinking from the 20-degree angle, this would be adjacent. So I'm thinking 100 cosine 20 this time. And as far as the direction is concerned, let's see, looking at this, That's a 70-degree angle. Both x and y are negative in the third quadrant, so I could go with cosine 70 degrees, sine 70 degrees, if I make them both negative to reflect that third quadrant angle. But I kind of want to put everything in terms of the 20-degree angle, so I am going to use the cofunction identities. And I'm going to say the cosine of 70 is the same as the sine of 20. And the sine of 70 is the same as the cosine of 20. And if you just think back to your trig, those are just called cofunction identities. Cofunctions of complementary angles are equal. All right, so what does W perpendicular look like? Once again, I'll take the magnitude times the direction. So I'm going to have a negative 100 sine 20 cos 20. And a negative 100 cos squared 20 degrees. All right, so there are the values of W parallel and W perpendicular. Next, let's take a look at the question part B here on the next page. The condition for the block to stay in place or slide down the inclined plane depends on the relationship between W parallel and W perpendicular. If too much of the weight is parallel, the block will slide. But exactly how much is too much? That actually depends on one other factor, known as the coefficient of friction, or mu. Rough materials like carpet or sandpaper have a large coefficient of friction, right? Stuff's less likely to slide. Smooth materials like glass or ice will have a very small coefficient of friction. Things will slide easily. The condition is actually this. The block will slide if the magnitude of W parallel is greater than the coefficient of friction, mu, times the magnitude of W perpendicular. Suppose that in our problem, mu was 0.65. Will the block slide? Well, let's go ahead and write this out. The magnitude of W parallel, we had that right here. That was 100 sine 20. Is that greater than mu, 0.65, times the magnitude of W perpendicular, which was 100 cos 20? All right, just to simplify the arithmetic a little bit, I could divide 100 out of both sides of this, get rid of those. And if I divide both sides by cosine 20, I know that's a positive value since it's a first quadrant angle, so no problem with the inequality. That says tangent 20 degrees is greater than 0.65. Let's check that out. Tangent of 20 degrees is about 0.36. And of course that's false, since that was the condition for the block to slide. In this case, the block won't slide. All right. How steeply could you incline the plane before the block will slide? And this actually points to why I was so careful to do everything in terms of the 20 degrees and kind of some of the manipulations here as well. Look at this line right here. Essentially what it came down to was whether the tangent of the angle of the inclination was greater than the coefficient of friction. So we can kind of make a general condition for sliding that the tangent of our angle, theta, must be greater than mu. So in this case, I want to know when is the tangent of theta greater than 0.65. Well, let's see. If I take the inverse tangent of 0.65, I get about 33 degrees. So it looks like that plane is going to have to be inclined more than 33 degrees in order to get this block to slide. All right, that brings us to the end of section 11.3.